Okay, so in this video I'm going to have a look at the commutative, associative and distributive properties of sets. Now just to remind you what they are, we had a look at these when we looked at natural numbers, natural numbers anyway. We had a look at, let's say, the commutative property was something like this. Well, it was if you have 2 plus 3 is equal to 5, well then 3 plus 2 is also equal to 5. Same with multiplying, if you have 2 times 3 will give you 6, 3 times 2 will also give you 6. So this is the commutative property here. The associative property was 2 plus 3 plus 4, and let's say the brackets were here. So we do what's inside the brackets first, that will give us 5 plus 4, which is 9. Now if you change the brackets, if you have 2 plus 3 plus 4 and you put the brackets here, well that will just simply give us 2 plus 4, 5, 6, 7 here, which will also give us 9. So we get the same answer in both cases by moving the brackets. That's the associative property. The distributive property then was, well, let's say we have 2 times x plus y. Well, effectively what we're doing here is we're distributing multiplication over addition or subtraction. So what we do is we multiply that 2 by the x, multiply the 2 by the y. So what we end up with here is 2x plus 2y. This is the distributive property, distributing multiplication over addition or subtraction. So with sets then, if we have, let's say, 2 sets, I'll do the commutative property first, it's the easiest one to look at. If we have 2 sets, let's say A and B, well, if you take A union B, that's A or B, well, that's going to be exactly the same as B union A. So in other words, everything in here is going to be exactly the same as everything in here in reverse. Or if you take A intersection B, that's going to be exactly the same as B intersection A. So this is our intersection here. So if you intersect A and B, you get this bit here. If you intersect B and A, you also get this bit here. So this is the commutative property of sets. So that works. Let's look at the other ones then, the distributive property. So we're going to have this universal set here, 0 up to 9. So I put them in a Venn diagram here. This is the set A, B, and C. So I've drawn them in here. So we're going to look at the distributive property. So how are we going to do that? Well, let's say, how will we do this? Well, let's say we look at union over intersection, and then we look at intersection over union. So let's first of all look at A union B intersection C. So this is like our multiplication. When we had 2 times x plus y, what we did was this kind of thing here. Okay, so that's effectively what I'm doing here. This is my equivalent of multiplying, and this is my equivalent of adding and subtracting, if you like. So let's have a look to see, is that equal to, what we want to see, is that equal to A union B? So I'm doing this bit here first. I'm doing this bit here first with union, and then I'm going to do this bit here with union. I'm going to intersect my answers. So in other words, it's A union B first, intersection, and then I'm going to do A union C. See, do we get the same thing on both sides? Well, let's do this left-hand side first. Well, A is just simply 2, 3, 7, and 8, isn't it? 2, 3, 7, 8. So let's just write that down. 2, 3, 7, and 8. I want to union. I want to do what's inside the brackets now. B intersection C. Well, B intersection C is this bit here. That's B intersection C, this bit here, 7, 8, and 9. 7, 8, and 9. So that's my left-hand side. So if I want to do the union of these two, that will just give me, let's see, 2, 3, 7, 8, 9. 2, 3, 7, 8, 9. Just writing down all the elements once. So 2, 3, 7, 8, and I've got a 9 here. Okay, so that's this left-hand side done. I did what's inside the brackets first, here, and I have union here, and this is A here. Okay, so now let's do the right-hand side and see do we get the same thing. Well, we got to do A union B first. So A union B is 2, 3, let's see, 2, 3, 7, 8. We have a 0, 4, and a 5. Okay, so 2, 3, 7, 8. And we have this 9 here as well. Let me just stick that in there somewhere as well. So we have 2, 3, 7, 8, 2, 3, 7, 8, 0, 4, 5, and we have a 9 there as well. So that's this bit here. Now we want to do our intersection as well. So I'm going to intersect. And then I'm going to do this part here, A union C. Well, A union C then is going to be 2, 3, 7, 8. 2, 3, 7, 8. That's this bit here. And then we've got 1, 6, 9 as well. 1, we got 6 and 9. Now really what I want here is the intersection of these two. So let's see, we have a 2 and a 2, so we'll put that in there. We have a 3 and a 3, so we'll put that in there. We have a 7 and a 7, so we'll put that in there. We have an 8 and an 8, so we'll stick that in there. We have a 0, there's no 0 here. There's a 4, there is no 4 over here. There's a 5, we have no 5 here. There is a 9, we have a 9 here. And that's it really. We have a 1 and a 6 here, but we know 1 and 6 on this side. So that's it. Now you can see that we got the same thing on both sides. So here what we've done is distributed union over intersection. So we did this first and we got 2, 3, 7, 8, 9. Then we did this on the right hand side and we got exactly the same thing. Okay, so that's union over intersection. So let's have a look now at intersection over union. So let's do intersection over union. So this time what we want to do is A intersection B union C. So we're going to do that and we want to see, is that equal to A intersection B, and then we want union, and then we want A intersection C. So really what we're doing here is we're doing this intersection, A intersection B, and then A intersection C, and we're putting union here in the middle. So let's do both sides. So we got to write down A again. So let's see, A is just, have it written here, 2, 3, 7, 8. Let me just do this in white. So we got 2, 3, 7, 8. That's A. Now we want the intersection then. We want the intersection of B union C. B union C. So let's see what that is. So B union C, all these numbers here. So we have 0, 4, 5, 7, 8, 9. 0, 4, 5, 7, 8, 9. Let me write all that down. 0, 4, 5, 7, 8, 9. So 0, 4, 5, 7, 8, 9. Then we have 2, 1, and 6. 2, 1, and 6 as well. Let me write that down. 2, 1, and 6. Now we want the intersection of these two, so that will just give me 2. There's a 2 here, yeah. So let's write down 2. There's a 3. No 3 over here. There's a 7. There is a 7 here, so we'll write that down. There's an 8 here. There's an 8 here. That's it. So the intersection of these two sets here is 2, 2, 7, and 8. Okay, so that's the left hand side. Now I got to do the right hand side here. So that's going to be A intersection B. So let me write that down. A intersection B. So A intersection B is just this bit here, and that gives me 7 and 8. So let me just write that down, 7 and 8. That's A intersection B. And we want to do union, and we want to A intersection C. A intersection C. Well, A intersection C is this bit here, which is 2, 7, and 8. 2, 7, and 8. Let's do that. That's going to be 2, 7, and 8. Now we want the union of these two. So it's 2, or sorry, it's 7 here. We have a 7, we have an 8, and we have a 2. And you can see that we got exactly the same on both sides here. So A intersection B union C gives us this 2, 7, 8. When we do this here, A intersection B union A intersection C, and do this bit out here, we do in fact get the exact same sets. So the distributive, or sorry, the what did we start with here? The distributive property, yes, does work for sets here in this example here. Okay, so that's our distributive property. Let's have a look then at our associative property. So again, I've done out a set here. This is our universal set here. We have an x, y, and z here, and I've written it out. I've done it out here. So let's look at our associative property. So let's see, how are we going to do that? Well, let's say, start here. We're going to say x is x union y union z, and we'll put the brackets here. Is that exactly the same as x union y union z with the brackets here? So let's do that first of all, and we do intersection in a few minutes. So let's write these out first of all. Now remember, you've got to do what's in the brackets first. So that will give me x union y. We've got to do that first. X union y is TVWS, and then we've got UZY as well. UZ and Y as well. And we want to do union, just take that there, a little bit off there, union, Z. So we got to write down Z then. So Z here will give us SUZX. SUZX. Okay, so we want to do the union of these two here, so that will give us T V W S. Now we have an S here as well, so I don't need to count that again. U, and we have a U here as well, so I don't need to count that a second time, so I'll just count that once. We have a Z here, again we have a Z here, so I don't need to count that again, so I'll just put that in there. And we have a Y here, and we have an X as well here that I didn't count yet, so we'll put that in there. Okay, so that's our left hand side. Let's do out our right hand side then. So we have X, so we just need to write out X first of all. X is T, V, W, and S. And we want to do what's inside the brackets here now. Y union Z. Y union Z. So Y is W, Y, U, Z. W, Y, U, and Z. W, Y, U, Z. And we have S and X here as well. S and X here as well. So we want to union these two. See, are they equal? Well, we have a T. We have T. We have V. We have W, and we also have a W over here, so I better not count that again. TVW, and we have an S, and we have an S here as well. Now we have W, which I've counted. We have Y, and we have U. We have Z, which I haven't counted yet. We have S, which I have counted, and X, which I haven't counted. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So T, V, W, S, Y, U, Z, and X. Yes, so these two are equal. So by moving the brackets from here over to here, we get exactly the same sets on both sides of our equation here. So remember, on each side you must do what's inside the brackets first. So you do X union Y first here, and then you union it with Z if you like. Here you must do Y union Z first, and then find a union with X. Okay, so let's see, does the same thing work for intersections? So let me just write it out first, and then we'll actually do it. So we have X intersection Y, and we'll put the brackets here, intersection Z. We want to see, is that equal to X intersection Y? Oh, not the brackets there this time. So intersection Z, we want to put the brackets here this time. So let's write down x intersection y first of all, okay? X intersection y. Well, there's x, there's y. X intersection y is just simply w. X intersection y is just w. So I'll just write that out. This is w. Now we want the intersection of that with z here, with z. Well, z is x, s, u, and z. X, s, u, and z. Okay. X, S, U, and Z, X, S, U, and Z here. Okay, so the intersection of these two is in fact a null set in this particular case. So here we're just going to get the null set. Now, will we get the null set on the other side as well? Well, X is going to be, X is TVWS, TVWS, so we write down TVW and S here. And we want the intersection of y intersection z. Y intersection z. Y intersection z is u and z. U and z here. So u and z. What do we get when we intersect the two of those? Well, we have nothing in common. U and z are not in here. So again, we get the null set on the right hand side. So in both cases, we do get the null set. So by moving the brackets from here over to here, we get the same thing on both sides. Now, very often when you do these, you will get some kind of a set here and some kind of a set here with elements in it, but in this particular case, we happen to get the null set. But this will work for all sets. The associative property will work for intersection and union. Okay, so that's it for the associative, distributive, and commutative properties of sets.